All right, guys, welcome to Math 0106. This is lesson 11. We're going to be talking about multiplying decimals. So let's look at number one. We have 6.4 times 3. When we approach this question, you approach it like you would normally multiply. So we line things up. We're going to do 4 times 3 first, which is going to give me 12. Let me do that in a different color. 12, we carry the 1. Then we multiply 3 by 6, 18, add the 1, and that's 19. The big concern is, what about the decimal? Well, because we have one decimal, the traditional way of teaching this is that we move it back 1, so we have to move this one forward 1, and we would end up getting 19.2. And again, what I recommend doing is ask yourself, round it. So let's say we have 6 times 3. If you do 6 times 3, you get 18. And 18 is pretty close to 19.2. Again, I round it down, so it makes sense that 18 would be a little less than 19.2. So guesstimating with numbers helps in terms of seeing if you did the decimal place accurately and if you multiplied correctly. Now, I will make one little note about this. Unlike subtraction, in addition, when you multiply, you amplify numbers very quickly. So the discrepancy in rounding grows the bigger the number is. So it's not uncommon to be like, say, 10 off or whatever. But for our case, if you're starting to get like 100 off or something to that degree, you made a mistake. In other words, if I thought the answer was 1 instead of 19.2, if I thought the answer was 192, right? But when I do 6 times 3, I get 18. I know I have a problem. If I thought the answer was 0.192 and 6 times 3 is 18, I know I made a problem. Or even if I just said 1.92, it's pretty low for such small numbers. I probably made a mistake. So the other thing to keep in mind is that what you're really getting tested on is your placement of the decimal more than anything else. So keep that in mind as well as you work through these questions. Okay, let's go on to the next one, number 2. So in number 2, we have to create space. In number 2, we have 5.6 times 0.4. I know it says 0.4. I like to not write the 0. I think the 0 confounds what you're looking at. So, but if you like to put the 0 there, put the 0 there. So again, we multiply. So 6 times 4 is 24. Carry the 2. 4 times 5 is 20. Plus 2 is 22. Notice here we have 1 and 2 decimal places, so I have to jump 2 spots. So the answer is going to be 2.24. And here, what you can do is you can think of, let's say 5.6 is roughly 6. Let's see, 0.4 is roughly 0.5. So I'm thinking half. So what's half of 6 when you multiply? I know it looks weird, but half of 6 is 3. So it makes sense that 2.24 is what it's going to be. Also notice that for both 6 and 1/2, I rounded up, right? And I know I'm not using the official rules of rounding necessarily for all of this, but I'm just trying to create easy numbers to multiply by. But irrespective of that, if I bumped both of them up, it would make sense that 3 would be a little bit above 2.24. So that's yet another measure to illustrate, hey, yeah, that makes sense. But I'm about to move on to the next question, but before I do that, I want to stress that the reason why I keep asking you to check your answers is it's easy to make silly mistakes. There's a lot going on at once when you're doing math problems. So the safest bet is always to, as you work through the problems, if you have a system to check your answers, go ahead and do so. Okay, so I am writing that incorrectly. Oh, I did it wrong again. I'm thinking of too many things at once. Okay, so the next one is 35.3 times 0.05. Here, unlike addition and subtraction, you don't have to line up the decimals. You just have to line up the digits. And we just attack it. So 3 times 5 is 15. Carry the 1. 5 times 5 is 25. Plus 1 is 26. Carry the 2. 3 times 5 is 15. Plus 2 is 17. We'll drop a line, put a 0, and we're going to multiply through. But all of these are going to become 0, so it becomes irrelevant. And then we add these two together. We get 5, 6, 7, 1. And now we look at the decimal place and we see you have 1, and then we have 2, and then 3. So you jump a total of 3, where we'll be at 1.765. So if here, this is a little difficult, but let's say we have, if we're going to check, we could say 35 times, let's say for 0.05, we know that's 5 over 100, going back to the rules we learned in the previous class. 5 over 100 is going to be times, these are both divisible by 5, so 1 over 20. And you can see that if you're going to divide 35 by 20, well, 40 divided by 20 is 2, so 35 divided by 20 would be a, so let's look at it this way. 40 divided by 2 would, 20 would be 2, and 40 divided by, 20 divided by 20 is 1. So you know that it's living between 1 and 2, and 35 is about 3/4 of the way up. So it makes sense that 1.76 is the answer. 65 is the answer, right? So these are just little ways that you can kind of guesstimate what the answer is. What I'm really trying to show you and trying to get you to do in general as you work through these is build up what's called number sense. And number sense is important even in the real world, because if we're talking about, if somebody's talking about, let's say you're going to make a big purchase and you're buying like a home or a car, you want to be able to understand what a percentage is, like what exactly am I paying more? Or even if you're just getting a credit card and they have something like 20% interest, you need to understand how much more are you paying for that money now. So you develop that with, as you develop number sense, and that's important because you need to have that idea of what ends up becoming of numbers when you multiply them together. You don't need to know exactly what they are, but have an idea so that when you make big purchases, for example, you have an idea of what it's going to be without looking at a device to figure that out. In any case, let's move on to number 4, 5.026 times 0.01. Again, we're just going to multiply. I'm just going to multiply the 1 here. So this is nice. I'm just going to rewrite. We saw earlier that when we with the 0, we could rewrite, put a bunch of zeros below, but that's not necessary. So I don't know why I said plus nothing, but we have 5026. Now we count the decimal places. So we have 1, 2, 3, 4, 5. So we count 1, 2, 3, 4. I need one more space, put a 0 here. So the answer is going to be 0.05026. Again, here, if we say 5 times 1 over 100, we're left with 5 over 100. And I don't know, the way I like to think about 5 over 100, if we reduce this is 1 over 20. Not sure if you guys are aware, but if you take a test and, let me say this. If you take a test, a lot of times tests are out of 20. That means each question's worth 5. So that just means that this is going to be 5%. We're going to talk more about this later, but percents literally are out of 100. So this also means 5%, which is 0.05. So both of these kind of align to 0.05026 being the correct answer. So hopefully that makes sense. If the rounding, the way I'm checking my work by rounding is a little confusing, don't stress over that. Wait till we get to the part where we talk about a little bit about percentages, and then rewatch this and see if it makes sense, if you're still struggling. Okay, cool. Let's move on to number 5. So again, number 5, if you look at it, it's nice because you're multiplying by 0.1. So because I'm multiplying by 0.1, I don't have to concern myself too much with the actual multiplication here. And you know what I'm going to do? I'm going to put that decimal right there. And then let's multiply. So we know we're going to get 123. 3, you can just rewrite the number because it's 1. We have two moves of the decimal place, so this is going to be roughly 12.33. Again, if I check, let's say 123 times 0.1 is 1 over 10. We know from the previous class that when you're dividing by 10, you just move the decimal place over, so it should be roughly 12.3, and that's exactly what it is. So in reality, you could technically even approach the original problem this way, right? Since we're multiplying by such easy numbers, we're dividing by 10, and you can see that that means that you just move the decimal place over, which would give me actually the same exact answer. So again, all I'm trying to emphasize here is as you work through questions, try to think about it in multiple perspectives. I found that to be a universal skill in mathematics that really helps me to catch the mistakes, because it's so easy to make mistakes. Any case, let's look at number 6. 47.013 times 100. Again, because it's well, I mean, let me not skip steps. We're going to multiply through by 0. This means that the first row is just going to have nothing but, we have 1, 2, 3, 4, 5. We have nothing but zeros. Then we go one below, we put a 0, and then we multiply through by 0. So we said there's 5. So 1, 2, 3, 4, 5. Then we have 1, so we put 2 zeros, and then we write the number. So 3, 1, 0, 7, 4. Okay, so as you go down from the ones place to the tens place to the hundreds place, you keep adding zeros, an additional 0. So this is going to be 4701300. Again, we see here we have 3 decimal places, so we have to move it 3 places over. So this is 4701.3. Okay. If you want a different way of looking at this question, then think of it this way: 47.013 times 100. If I write it horizontally, because I have 2 zeros, that's really just meaning you're going to move it 2 places over to the right. And this would be 4701.3. And this is just a different way of thinking about it, and they both get you the same answer. Also on exam, it doesn't matter how you do it as long as you get the correct answer. So if you're working through these problems and you're like, oh, I like that better than that, then use that method. Also, again, want to stress, I'm not pausing, but I hope that you are pausing, and as you get comfortable with the material, you are doing these problems without listening to me and seeing if my work matches up to your work. Okay, so in the next one, notice I switched the numbers here. They're writing them horizontally, so to transcribe them vertically is just like when we were doing addition and subtraction. You just rewrite them. But what we like to do in multiplication is put the one that has more digits on top. Notice I didn't say put the bigger number on top, because 2.3 is actually bigger than 1.12, right? And we're saying the one that has more digits. And so now we're going to multiply. So this is where we actually start getting into a more complicated case in terms of multiplying. So again, we multiply 2 and 3 together. That gives me 6. Then we do 3 and 1, which is 3. 3 and 1 is 3. When we go to the next line, we put a 0 first, and then we multiply. So 2 times 2 is 4. 2 times 1 is 2. 2 times 1 is 2. Next, we add. So 6, 7, 5, 2. We count how many times the decimals move over, 3, so we jump 3. So this is going to be 2.576. And again, I'm just going to use a little common sense here and see what happens. So notice if I say 2 times 1, if I just round these, 2 times 2's here, 1's here. I don't know why I flipped the order. It doesn't really matter. But 2 times 1 is 2. So if my answer is 2.5 something, that seems to make sense. Also notice, in this situation, I rounded down, so it makes sense that my result would be a little less than the final answer. Okay, let's move on to the next one. So that was number 7. We are now on to number 8. So with 8, instead of writing the X, which is the multiplication symbol, they used parentheses, which is another way of saying multiplication. So they're just trying to expose you to all the different ways that you can see a multiplication situation. You just, again, like we did in the previous one, just write it vertically and you're ready to go. Okay, so we're going to do 2 times 4, which is 8. 3 times 4, which is 12. Carry the 1. 4 times 4 is 16. Plus 1 is 17. We go to the next row. Now we're going to use 3. And we need to put that 0 there to keep it aligned. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Go to the final line, put 2 zeros, and we're doing 2 times 2, which is 4. 2 times 3 is 6. 2 times 4 is 8. And then we add them together. So when I add this, I get 8, 8. I guess 7 and 4 is 11, plus 9 is 20. Carry the 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 6 is 11. Carry the 1. And this is 10. So again, we see 2 and 2. So we jump a total of 4, which would give me roughly 10. So the answer here is 10.1088. And again, I'm going to round this. So I'm going to say, let's say we say it's 4 times 2 is 8. 10 is pretty close to 8. I think I did a good job. Again, notice I lowballed it. So that's why 8 is on the floor as opposed to the ceiling. So you know your final result should be a little bit higher than 8. Again, want to emphasize that with multiplication, the gap tends to grow as the numbers get bigger. So you notice previously the difference was plus or minus 1. Now we're seeing it, we're getting beyond 2 as the plus or minus. But it's still within reason. Okay. One other comment I just want to make real fast here. And I'll go back over this later. The reason why you're adding these zeros, let's just be clear about something. The reason why we keep adding zeros is what you're really doing when you do 4.32 times 2.34. Well, let me just make it cleaner by writing 234. So let's just look at it that way. And actually, I'm going to take away this decimal here just to avoid confusion. We can insert it back later. The decimal is really dealing with dividing. But when you multiply, what you're really doing, what the algorithm is really saying is you're cutting up this number. And it doesn't really matter which one you're doing, but we're going to assume it's the bottom one. We're cutting up the number as such. So you can see here that when I'm multiplying 2 by all of these values here, I'm actually multiplying, if you distribute, so this is a property, we haven't discussed it, but we will later on. If you distribute, you're doing 432 times 200. That's why you have the 2 zeros there. Plus 432 times 30. That's why you have the 1 0 there. And then the 432 times 4. That's why you have no zeros here. So that's why it actually works out. That's what the algorithm is really saying. So I like whenever possible to show you why the math works as opposed to you just memorizing a bunch of stuff. In any case, let's move on to the next one. So 1 second while you listen to me erase. Okay. So the next one, number 9, I got to put the bigger number first. So this is 10,000. Well, you know what? Let's do it this way. So since I'm just multiplying by 10,000, let's think about this. We have 1, 2, 3, 4 zeros here. We know when we multiply by 1, you get the same number. So I don't need to do the vertical algorithm to solve this. I can if I want to, but let's be more efficient here. So if I have 1, 2, 3, 4, that means the numbers, first off, multiply by 10,000 means the number is going to get bigger. So, and this just means I'm going to move the decimal place over 4. So 1, 2, 3, 4. So this would be 20,370. And it's pretty obvious because if you multiply 2 times 10,000, you get 20,000. So 20,370 seems pretty accurate here for what we're doing. So hopefully that makes sense, and you see why I just went ahead and did it that way as opposed to multiplying vertically. And I hope that, look, if you're looking at this, you're like, oh, Mr. Anderson, why are you doing these things? And you find it to be confusing, then do it vertically. It's fine. And you should compare your answer to mine and see if we get the same thing. So on this one, it's the same thing. Number 10. Since we're multiplying by 1, I don't need to do the vertical alignment. We have 3 places, so note you have to go to the back of the whole set when you have a number less than 1. So this means I'm going to jump 3 times. So now I'm going to jump 3 times, but this is 3 times forward. So this gives me 7.4213. And what I want to stress here is that when you're working through it, ask yourself, does it make sense? So is the number getting smaller when I'm doing this, or is it should be getting bigger? Notice in the previous problem right here, what was this? What number was this? I covered it up. Oh, it's 1009. And number 9, when we did 9, we multiplied by 10,000, so that makes sense the number would be getting bigger. But if you multiply by 0.001, that means the numbers should be getting smaller. So now on to number 11. Notice that 142 is bigger than 15.3. It doesn't matter as long as you want to put the one that has more digits on top. So it's fine the way it's written. But if you wanted to flip it because you just like the way it looks the other way flipped around, you can. It doesn't matter. So we multiply. We get 3 times 2 is 6. 2 times 5 is 10. Carry the 1. 2 times 1 is 2. Plus 1 is 3. Then we go down 1. So we got to put a 0. 4 times 3 is 12. Carry the 1. 4 times 5 is 20. Plus 1 is 21. So this becomes 2. 4 times 1 is 4, plus 2 is 6. Then we'll go 1 lower, we'll put 2 zeros. If you feel that the carrying effect confuses you, my advice is erase the top. You can also do this in different colors if that helps to make it clear. So maybe if I wanted to, I could do this line. Let's do this line here in purple just to make it distinct. But if we're multiplying by 1, the nice thing is that you just recopy what you had before. So just rewrite 351 or 153 depending upon how you're looking at it. And we just add these up. So I'll finish in a different color. So this becomes 6, this becomes 2. This is 4 plus 3 is 7. This is 11, carry the 1, 2. So we jumped once, so we should have a decimal here. So the final answer is 2,172.6. And again, ask yourself, if I did 140 times 15, right, this would give me what? So this is roughly 14 times 15, and then you tack on a 0, right? So let's see here, that's 74, 1. Put those together, you're getting 11, 210, and then I said tack on a 0 because it's 140, not 14. So it's 2100. So 2100 and 2172.6 are pretty close to each other. I feel confident with my answer. Let's move on. So we're on to number 12. And again, 12, they're trying to scare you by putting a decimal on the top. It doesn't matter. You're just going to multiply the digits out, figure out what the answer is. And once you get the answer, move the decimal place over 3. And I hope that you guys, as you're doing this, again, you're not just watching me do these problems. That is not the purpose of this. The purpose of it is to do the problems on your own, then see how I'm doing things. And once you see how I'm doing things, compare your work to mine and see that we're getting the same thing. So pretty straightforward. As I was explaining that, I was solving the problem. I hope there's no concerns there. Again, like I said before, because there's 3 decimal places right here, right? We got to move 3 forward. So this gives me 166.912. And I'll check. Let's see here. If I say 512, I'm multiplying by 0.326. So this is roughly multiplying by 3 over 10. Okay. So is 51.2 times 3. Notice because you divided by 10, you just move it over 1 times 3. Is that going to be roughly 166? So again, we're estimating here, so I'm not even going to do 51.2. I'm going to say, hey, is 50 times 3, which is 150. That's pretty close to 166. I feel pretty confident about my answer. It's okay. So again, really more than anything else, the rounding to check is to see, am I getting approximately the same sort of value? So we're talking about moving decimal places over. So had I messed up with the decimal place and got 16, then I know I made a mistake, right? So hopefully that makes sense. Let's look at the next one. So the next situation is a little different. Actually, I'm going to go over here and do it over here. The next situation is a little different. It's asking you to convert into dollars. So we know cents just means you move it the decimal place over 2. So this is just going to be 0.58. I'm literally just moving it over 2. On this one, the same thing. It's going to become 1.72. Okay, and 17 and 18, they're just giving you, it's the same sort of situation. They're just giving real life examples. So we discussed in a previous video, area just means you multiply things together. So we're going to do 12.5 times 7.2. Notice I switched the order, and the reason why I switched the order was because I like the one with the most digits to go first. 14 and 3 is 17, carry the 1. 7 times 1 is 7, plus 1 is 8. I hope at this point you don't need me to thoroughly explain what's going on. You're able to see. If we have 2 decimal places, then we're going to move over, we get 90. So 90, let's see if that makes sense. If I did 10 times 7, notice I'm getting super lazy here. I'm just going straight to 10, but this is going to give me 70. So 70 is not too far off from 90. Notice that if I had done 12 times 7, that would give me 84, which would put it even closer. So just different ways of thinking about it. Sorry, the reason why I'm kind of going fast is I got about 3 minutes to do the rest of these problems. So actually, I'm going to stop at 18. I'll do 19 and 20 in the next video. So 18 here, we're going to do, I'm going to put the bigger number on top, 6.6 times 5.4. If you do it the other way, it's fine. 6 times 4 is 24, carry the 2. 4 times 6 is 24, plus 2 is 26. Put 0, that's 30. 30 and 3 is 33. And let's finish it off. So if we add them, we get 4, 6, 5, 3, decimal place 2. So this is 35.64. And again, if I just round this to 6 and this to 5, 6 times 5 is 30. That's pretty close. I feel confident with my answer. One other comment here before I go. Technically, the answer is feet squared here, and this is meters squared. We're not going to emphasize this in this course, but what it is, you're multiplying dimensions. And so when you multiply dimensions, this is like saying, like earlier we had said, like, for example, if I did the prime factorization of 4, this is 2 times 2. So 2 times 2 is 2 squared. It's the same idea. So if I multiply feet by feet, I would be getting feet squared. If I multiply meters by meters, I would be getting meters squared. This is something to get kind of comfortable with. It's not going away. So keep that in mind. You're not going to need it for this class, but it's useful in future classes. Okay, I'm going to do 19 and 20 in a separate video because these problems deal with something called PEMDAS, order of operations, different topic. I don't know why exactly it's here, but we'll pick it up in another video. In any case, I hope this makes sense, and I'll catch you guys in the next video.